Ladies, and welcome to room 328, coming at you live from room 328. Not at home today, so today there won't be any piano playing by the cats or dogs needing to go in or out, although I can't promise that Mrs. Christ won't pay a visit. Who knows? All right, so we're moving on to chapter 10. I know we're skipping around a bit, but chapter 10 is about blood, and since we were just talking about with the bones, that hematopoiesis takes place in the bones, and that is blood cell formation. Seems like a good time to stop and take a look at our blood. So remember that blood is a connective tissue, which means it has loosely packed cells in a chemical matrix. So today we're going to start to talk about some of those cells, one kind in particular, just to get us kicked off. And then your test over this will be next Friday. And I will also be gone next Friday, unfortunately, but my husband's having surgery, and I'm hoping to take away from his surgery some interesting stuff to bring back to you and talk with you about as we move forward into muscles then. All right. So the formed elements are the cells of the blood. There are 3 different types of blood cells. There are the red blood cells, which we're going to talk about today, the white blood cells, and the platelets. And the platelets are actually pieces of larger cells, but we'll worry about that another day. So let's start with the red blood cells, the erythrocytes. Erythrocytes, we'll talk about abundance first. In a cubic millimeter, so think about how big a millimeter is. A cubic millimeter, there are between 4 and 6 million red blood cells. You have a ton of red blood cells. Yay, we like that. Red blood cells don't live very long. They only travel around in your blood for about maximum of 4 months. And the reason for that is because when they mature, they get rid of their organelles, because they're making room for hemoglobin. So mature red blood cells are basically sacs of hemoglobin. Remember that hemoglobin is a functional protein. And so these red blood cells, because they're just sacs of protein, they makes them great at what they do, at their job, but it also makes it so they can't repair themselves. They don't have any organelles, so they have nothing to build proteins with or to make new structures, so they can't repair themselves. The dead erythrocytes are gotten rid of in the feces and are part of the reason why feces is typically brown. When we get to that chapter, we'll talk about atypical, but that's a whole other ball of wax, and that's for next semester. All right, so I said that they're very good at their function. What is their function? Their function is to carry oxygen in the blood. That's what the hemoglobin does. Hemoglobin is specially designed for that. Now, we said that blood cell formation in general occurs in the red marrow of the bones. The specific formation, so we have 3 different kinds of blood cells. Which kind are we going to make? The specific formation of red blood cells, still beginning in the marrow with those stem cells, is called erythropoiesis. So that poiesis part means formation, and this time we're making red blood cells specifically, not just blood cells in general. So what causes erythropoiesis to happen? A hormone made by the kidneys targets the stem cells in the red marrow to produce red blood cells, specifically red blood cells. And this hormone is called erythropoietin. There we go. This hormone is produced by the kidneys, targets the stem cells in the red marrow to form red blood cells. Now, as I said, they don't live very long because they do kick out their organelles as they fill up with hemoglobin. And yes, they are producing that hemoglobin when they have organelles, but eventually they produce so much hemoglobin that the organelles don't fit anymore. And you don't need them anymore because we've got the protein we need to carry the oxygen. Now, the fun thing about red blood cells is that red blood cells determine what type of blood we have. So there's two ways that we type blood. There is the ABO system, and we'll take a look at that. And then there's the RH system, and that's what determines if your blood is positive or negative. Okay. These are two different genes. They're completely independent of one another. And we'll take a look at how the genes work here. So we're going to start with the ABO system. And for that, we'll go over to the iPad. Okay, so I've made some charts here. For the moment, we're just looking at this top chart. Ignore the one down below. So blood typing using the ABO system. So there are 4 possible ABO blood types. Type A, sorry, those lines are annoying me. We'll put some dots on there instead. Okay, so type A, type B, type AB, and type O. And what these blood types mean is what proteins do you have on your red blood cells? So these proteins are called antigens. And we will encounter these again when we get to the immune system. So I think that will kick off second semester perhaps, or very close to it. So if you have type A blood, that means that your red blood cells have the A antigen on them. If you have type B blood, your blood cells have the type B antigen on them, the B antigen on them. If you have type AB blood, your red blood cells have both the A and B antigens. If you have type O blood, there are no antigens on your red blood cells. Okay, so what do these antigens mean? We have, our bodies have an inventory of what proteins, and these antigens are proteins, what proteins belong in our bodies. And so when our bodies encounter a protein, any protein, they encounter a protein, they run it against the checklist of what belongs in our body. And if it doesn't belong in our body, then our body launches an immune response to that antigen, to that foreign protein. So these antigens, if you have type A blood, your body knows A antigens belong here and they're not going to fight it. So I'm kind of getting ahead of myself here. Let's talk about genetics for a second. So remember that for many traits, and it's true of blood typing, you have 2 alleles. One that you got from mom, one that you've got from dad. So if you have type A blood, this is an example of multiple alleles, this whole ABO thing. Multiple alleles means that there's more than 2 possibles that those 2 alleles could be. They could either be A, B, or O. So there's 3 possibilities, but you only have 2. If you have type A blood, you may have 2 A alleles, or you may have an A allele and an O allele. A is completely dominant over O. If you have type B blood, you may have 2 B alleles, or a B and an O allele. Once again, B is completely dominant over O. If you have type AB blood, this is an example of codominance, where you can only have an A allele and a B allele. Both of them are present in your body. Both of those are shown in your body. And if you have type O blood, you must be recessive. Homozygous recessive, you can have an O and an O. So let's talk about what kind of blood each of these can accept. This is so much more fun when you're actually in front of me and I get to like shout it out to you and ask for your input. I should have staged it, had Senorita come up or something. Okay, so type A blood can accept itself, of course, because it knows that type A antigen. Can it accept type B? No, because it would see that B and say, that's not on my list, that's not on my inventory, you don't belong here, and it would start an immune attack on that type B blood. That would be no bueno. Okay, AB blood, same deal, okay, because the AB has the B antigen on the cell, and so the type A blood will recognize that as foreign and attack. Type O blood, that's just a naked little red blood cell. There's nothing to get upset about. And so type A can accept type O. Type B blood, of course, can accept itself. It cannot accept A because, once again, that A is a foreign antigen. It cannot accept AB because there's an A antigen on there and that's foreign. But once again, O is just a naked little red blood cell, nothing to get upset about, no antigens to fight off. Type AB blood can accept itself, of course. That would kind of stink if you couldn't accept your own blood. They can accept type A blood because they have the A antigen, and so they recognize that as something that is familiar and won't attack it. They can recognize type B blood as something not foreign. And once again, those naked little type O bloods. And so type AB is said to be the universal acceptor. Type O blood cannot accept A. It can accept itself. Let's get that down. Okay, it can accept itself. Cannot accept A because those A's are foreign. The B's are foreign. So AB is going to be foreign as well. They can only accept their own blood. Own type of blood, I should say. Let's turn this around. Who can they donate to? So we can kind of get this by looking at our acceptance list, but type A blood can obviously donate to itself. It cannot donate to type B blood because it would be rejected. It can donate to type AB blood. It cannot donate to type O. Type B blood, same deal. It can donate to its own type or to type AB, but not to A or O. AB blood, pretty limited. It can only donate to itself. Type O blood can donate to everybody. And so for this reason, type O blood is the universal donor. So if you have type O blood, and you ever give blood, which I encourage you to do if you're able to do that, they will be on you forever and ever to get your blood. We really want your blood because of that universal donor. So if you are, let's say you're in an accident and you're admitted to the hospital and you need blood, before they can, it's going to take a little bit of time, not a horrible amount of time, but a little bit of time to figure out what your blood type is. They'll give you type O blood. It doesn't matter what type of blood you have. They give you type O and you're fine. So that's why they really want your blood. Now, the good news is that type O blood is the most common. At least in the United States it is. Okay. And that's because if you go back to these alleles over here, notice that you could have a type B parent, a type O parent, type A parent, sorry, and still end up with that combination. It's a lot more common combination than the other combinations. So that's one of the genes for blood type. The other is the Rh system. And Rh is a different protein, a different antigen that has a different gene involved with it. So it's completely independent of the ABO thing. The Rh is an abbreviation from rhesus monkeys because it was first discovered in rhesus monkeys. And this works in a similar way, but a little bit more simplistic because we don't have the multiple alleles. So here we have blood typing, Rh factor. So with the Rh factor, you are either positive or negative. And once again, this is a separate antigen. And if you are positive, if your blood is positive, you have this antigen. And if you are Rh negative, you don't have the antigen. That's all there is to it. So pretty straightforward. We'll take a look at the alleles that are present here. If you are Rh positive, you might have 2 positive alleles, or you might have 1 positive and 1 negative allele. So positive is dominant over the negative. If you are Rh negative, you have to have 2 negative alleles. So let's talk about the acceptance factor, because this one gets kind of funky. So Rh positive blood can accept Rh positive blood and Rh negative blood. Okay, that's pretty straightforward. We can handle that. Rh negative blood, the first time, it can accept itself. We'll get that out of the way, obviously. Okay. If it's their first exposure to Rh positive blood, they can accept it. But after that, any other time that they are exposed, they will have a response to it, a negative response to it. Your body will start to attack those cells, those Rh positive cells. And the reason for this is I told you about that inventory that your body takes of the proteins that belong in your body and comparing that. Okay. So your body builds up that inventory. When you're born, you don't have too much of a defense mechanism as far as immunity is concerned, but you build it up over time. Well, this would be an example of that, in which the first time an Rh negative person is exposed to Rh positive blood, their body's like, oh, I don't know what to do about this. So it doesn't reject it, but it learns. And then the second time you're exposed to Rh positive blood, mounts the attack, the immune system kicks in and attacks it. So where this becomes an interesting factor is with pregnancy. So if mom is Rh positive, there's never going to be a problem. The baby can be Rh positive or Rh negative, and she's not going to fight the baby. But notice that Rh negative baby, this will be their first exposure to Rh positive blood. So if any time later in their life, after they're born, they are exposed to Rh positive blood, their bodies are going to fight it. They're going to build up that immunity to the Rh positive blood. If mom is Rh negative, we'll start with a baby that's Rh negative, no problem. If the baby is Rh positive, it depends on if this is mom's first exposure to Rh positive blood. So it depends on the exposure number. If this is her first exposure, no problem. But if she has been exposed to Rh positive blood before, now it's the second time or third time, whatever, her body is going to attack the baby's red blood cells. And so the baby will likely be born. They're cyanotic. So the blue baby. Now they can do things, they can give mom treatments that help her body to not reject the baby's blood. One of the downsides of those treatments though is it's somewhat of an immune suppressor, and so that means her immune system isn't at its best, which means that she could become ill from other things. It's not working as well as it possibly could. But that's the best case scenario, is to take those medications. Otherwise, baby will definitely be born cyanotic. So I think in your clinic questions, there's a question specifically about this when we get to the clinic for this particular chapter. All right. And so there we are with erythrocytes, the red blood cells. So if you have any questions, obviously I'll be back on Monday and we can go over anything that you might have questions on from this. I hope you have a good day today. I hope the test went well, and I hope you didn't bug Mrs. Johnson during the test about the question that was about her.